Today we're going to look at GCF and difference of squares. So what is GCF? It is an acronym for greatest common factor. And so it's the highest degree or largest term that evenly divides all of the terms in the expression. So we're going to do a few of these together. So we're going to identify the GCF if there is one. And if there is one, we're going to factor it out. So for number one, I'm going to start with the number pieces. 6 and 4. Are those divisible by something? And that'd be both divisible. Well, both of those are divisible by 2. And that's the biggest number that divides both 6 and 4. Then I'm going to move on to variables. Well, they both have an x, so then the GCF is 2x. But with y, only the 6xy has a y piece and not 4x, so that's not part of the GCF. So then to factor out the GCF, what you do is you write it out front and then you're going to divide each term by it. So 6xy divided by 2x would leave you with 3y. 4x divided by 2x would only leave you with 2. And so right here would be factoring out your GCF and what you would be left with. So let's do it again on number 2. If I look at the numbers, I have 7, 3, and 6. There isn't a number that divides all three of those other than the number 1. And 1 isn't ever considered a greatest common factor because it divides everything. But now let's look at the variables. X to the 9th, x to the 5th, and x squared. Well, they all have an x, and they all have at least 2 of them. So the GCF for this one is going to be x squared. So to factor it out, you write it out front, and then we're going to divide each term. 7x to the 9th divided by x squared is 7x to the 7th. Minus 3x to the 5th divided by x squared is minus 3x cubed. And then if you divide 6x squared by x squared, you're left with just 6. So that would be the factored form. Now on 3, same idea. We're looking at 4, 5, and 3. Again, none of those are divisible by the same number other than the number 1. So now let's go to variables. X squared, x, but then 3 doesn't have any variable with it. So I can't factor out an x from all 3 of these terms. When we have a situation like this, this tells us that there's no GCF. For that expression, there is nothing that I can divide all 3 by. And that's going to happen sometimes. Okay, number 4, 12 and 27. Well, those are both divisible by 3. And then x squared and no x's means the GCF is only a 3. And then divide each piece by it, and we would be left with 4x squared minus 9. And that's how you factor and identify a GCF. Now, you're going to do a lot of what we call factoring this trimester, and it's the process of finding what 2 polynomials multiply together to produce a desired expression. There are lots of methods for factoring, and we're going to show you several over the next several days. And as long as you get good at one of the methods, that's fine. They're all going to give you the same answer. It's just how you get that answer that is different. So you're going to be given a web or a reference sheet that looks kind of like this. Maybe some of it's blank for now. But the first thing that you're always going to do is factor a GCF, if it has one. And we saw sometimes it doesn't have a GCF, and that's fine. But if it does, then that's what we need to do first. Then you're going to figure out, well, if after I factor out the GCF, what type of polynomial is left? And today, we're only going to work with binomials, which are two terms. If you have a binomial, you're going to see if it's a difference of two squares. Now, there's key words here. First one being difference, meaning you have to have subtraction. If you don't have subtraction, then you go to no, and in that case, you're done. You can't do anything else. But if you have subtraction and it's a little much, and both terms are perfect squares, then we're able to factor. We're going to go through that process together. And just remember, your perfect squares, you've worked with these a lot in Algebra 1. They're the numbers 1, 4, 9, 16, 25, and so on, right? We should know all of those up to 100 and then probably even some afterwards. So let's get some practice at these. So on number 5, 25x squared minus 9. First thing you always do is look for a GCF. Is there something that divides 25 and 9? And in this case, there's not, other than the number 1. What about variables? X squared and no x. So this case has no GCF, which can happen. So now we're just left with the same problem. It didn't change at all. Is it a difference of two squares? Well, let's see. Is it a, is it a difference? Yep. Do we have perfect squares? 25x squared is 5x times 5x. 9 is 3 times 3. So we do have a difference of two squares. So to factor it, we're going to set up two empty binomials. One is always addition, and the other is always subtraction. And it doesn't matter which one you write first. It's the same way either way. The beginning of both of these binomials is going to be, well, what was the root of 25x squared? That would be 5x and 5x. Well, the other part would be, what is the root of 9, which is 3? And this right here would be my answer. Now, what's great about factoring is you can check. If we multiplied this out, 5x times 5x is 25x squared. 5x times negative 3 is negative 15x. Positive 3 times 5x is plus 15x. And positive 3 times negative 3 is negative 9. And when I go to combine my like terms, those cancel. And if I have factored correctly, when I multiply my answer out, I should get the exact same problem that I began with. We did here, so that's how we know that this is the correct answer. Okay, let's look at number 6. Is there a GCF? In this case, there is. And remember that part of GCF is greatest. So you want the largest number that divides both 16 and 64. And there's a couple of them. But the greatest is going to be 16. You have to make sure you get the greatest. If I factor that out, 64x squared divided by 16 is 4x squared. And then here's where I see a lot of students make a mistake. You've got to remember that 16 divided by 16 is 1. All right, so GCF has been pulled. Is what's inside the parentheses a difference of two squares? Because right here is really what we're focused on. The GCF's just hanging out front. Is it a difference of two squares? Well, I don't have a difference, I have a sum. So even though 4x squared and 1 are both perfect squares, this isn't a difference of two squares. So I can't go any further. My final answer would be 4x squared plus 1 and then the 16 out front for the GCF. And I can check this one just like I did the other one. Distribute your 16 and you should end up with the same answer. Okay, 7. Is there a GCF? There is. And in this case, your GCF is 4. That's the largest number that divides both of these terms. So factor it out, and we would get 4x squared minus 9. Now, again, you're only looking here at this stage. And you go, okay, that's a binomial. Is it a difference of two squares? And it is. We have a difference because of subtraction, and 4x squared and 9 are both perfect squares. So when we write this one out, we just have to make sure, don't drop your GCF. That has to tag along. And I'm going to set up my empty binomials. For difference of two squares, we know that one has to be plus and one has to be minus. And then how do we get our numbers? Well, they're both going to start with the root of 4x squared, which is 2x. And then they're both going to end with the root of 9, which is 3. So we're thinking that this right here is our answer. Well, let's check it. When you have a GCF out front, there's a couple of ways that you can check. You can decide, do you want to distribute your 4 into the first binomial? Or do you want to multiply your two binomials together first? It doesn't matter what route you take. One thing that you just have to remember is I can't take this 4 times all 4 pieces. That's not how the distributive property works. So to help me remember that, what I do most of the time is I'm going to leave my 4 out front and I'm going to multiply my two binomials together. So 2x times 2x is 4x squared. 2x times negative 3 is negative 12x. And then I've got a plus 12x and then minus 9. Combine my like terms, these are gone. And now I can distribute that 4, and that gives me 16x squared minus 36, which is the problem that I began with. So I know that I probably got the right answer, just right here. Okay, so that is a difference of two squares. We're going to get into factoring ones that aren't binomials soon, but we're going to kind of go through a process on, like, again, how can you check if your answer is right? So for these, we are going to see if what comes first is the answer, the factored form of what is on the right-hand side. So you're basically just doing a check. We're going to multiply this out and see, do we get this? So let's find out. If I start multiplying here, okay, my x's cancel out and I have 4x squared minus 9. Is that the same as 4x squared minus 6? No. So if in my check I get something different than the original problem, I know something has gone wrong. Okay, let's do the same thing with 9. That negative 3x has to get distributed to everything inside the parentheses. And remember, x times x squared is x cubed. Let's see, minus 6x squared, and then plus 3x. Lots of sign changes there. Does that match what's on the right-hand side? Yep. So this one is true or correct. All right. If you are doing this at home, pause the video and I want you to try 10 and 11 on your own. If you are done with those, then hit play and you can check your work. So I'm going to multiply them out real quick and see if they work. Okay, so we got one yes and we got one no with those. On 12 and 13, these are similar, but we want to make sure that we understand what this squared out here means. Last chapter, we talked about how you can never distribute an exponent. Never, 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 never. You have to understand that that means x plus 1 times x plus 1. Now, when I multiply this out, do I get what was right here? And in this case, that's a no. And we're going to do 13 is almost the same process, but I do have a GCF out front. So remember that this squared is only getting applied to the binomial. I have a choice. I can distribute the 2 to the first binomial, or I can multiply the binomial times the binomial. I tend to go with binomial times binomial first. So that's what I'm going to show here. Combine your like terms. And now I'm going to distribute that 2. And I can see from up above, those do match. So this one would work, or it would be true. So this entire chapter, check them. Check your answers. Hey, now we're going to start getting into reasoning through what could go in these boxes. On 14, I know when I multiply these first 2 terms, that's going to end up giving me what I start my answer with. So the only thing that I can multiply by x and get x squared would be an x. And I can test it real quick. If I fill in an x there and I multiply these together, I get the answer that I was looking for from the right-hand side of that equation. And you can do that every time. So you need to be multiplying these out to check your answers. That's going to be what saves a lot of us from just little errors or just kind of going too quickly. Okay, for 15, that's the same idea. I know that whatever I multiply here and here has got to give me this first one. Well, x times what would give me 3x squared? Well, I'm thinking that that's a 3x. Well, let's test it. If I multiply this out, combine your like terms, I do get what I began with. So that helps tell me this is my correct answer. Okay, now the same idea can be done for not the leading term. You just have to remember that when you multiply this out, when you multiply the 2 last numbers, that's going to give you what you ended with. So 4 times what is 8? We're thinking this is a 2. And we're going to multiply it out and check if that actually works. And combine your like terms. And I can see, yep, that definitely has to be a 2. Okay, if you're doing this at home, pause the video and see if you can do 17 on your own. Okay, it's the first number that's missing. Well, I know if I multiply both my first numbers together, I've got to get a 6x squared. So What could this possibly be? Probably a 3x, but let's test it. Multiply this out and let's see if 3x is true. It's looking like it's going to be good to go. Combine your like terms. And there we go. Okay, this activity is just to get you started on other factoring we'll be doing the next couple of days. So really reference your flow chart and make sure that you are checking your answers.